Hello, welcome back to the bootcamp. And today we're gonna start with the module two, to learning about the basic fundamentals of blockchain programming, and also first we're gonna get the introduction to the blockchain technology to help you to understand why we need this technology. Now, first, as again, there's also a very interesting article on Polkadot.com where you can find the blockchain explanations, a practical guides from the concept to the use cases, where it's explained pretty much everything why you need the blockchain in this era, and also why the blockchain is created and what's the problem that it's trying to solve. First, from my perspective, to understand what is a blockchain and why we need that, we also need to recap a bit on what is a Web3. So there's a lot of definition of the Web3. Some people think is Web3 basically the NFT, or is this a blockchain, or it's a crypto economy? From a standpoint, none of that are correct. But those are there's an spread the true meanings of the Web3. To understand why we need the Web3 technology, we have to go back a bit on the generations of the web technology. So in the Web 1.0, we basically just read static, read only web pages. In the Web 2.0, we have read and write, information centric and interactive. And in the Web 3.0, read write all, where the user centric, decentralized, and also private and secure. I'm gonna go into the two details in the later slide. So in the Web 1.0, we have the three stakeholder: the webmaster, internet, and also the user. The webmaster gonna be the one who control all the content that you're gonna see on the internet, and you as the user only have the permissions to read the data, but doesn't have any allowance to update or write to the data. And that's how the Web 1.0 works. In the Web 2.0, it's basically also the mainstream web technologies that we use nowadays. The Web 2.0, we have the user generated content, interactive activities, and also creativity, social networking, collaboration, communications, open it but not less transparent. And in the Web 2.0, we had a lot of new applications like Wikipedia that you use basically every day, and YouTube, where the user can upload new videos and also view the videos from all the others. Facebook, where the user can upload the post and also view the post from the other. LinkedIn, where you can basically post job hirings positions, and then you also view the content from the other. Twitter, Flickr, all those as well. And you can see now the user has the right to the ability to upload and also to update the content on the internet. But the problem of Web 2.0 is digital services built with using Web 2.0 technology is stoppable, corruptible, and also unreliable. In the Web 3.0, the Web 3.0 aim to deliver the solution to building resilient digital services, and it solves the core problems that are not solvable with the existing traditional technology, and it get rid of the dishonesties, single point failure, data manipulations, network downtimes, centralized governance, monopoly, ownership dispute, and also the inequality in power distributions that the traditional technology is currently have. In that way, to fulfill all the attributes of the Web3, we need a new infrastructure. And because the data is the most crucial and valuable commodity in the digital era, how we can fulfill those? In that way, we need another architecture. We need the data structure and technology that allow you to store the data in an immutable way, but also in the open way. And here we have the blockchain technology, where it's basically a chain of block. We're gonna go back to the visualization later, but here let's take a look at the definition it mentions on Polkadot blocks website. And the blockchain as a decentralized public ledger, a blockchain is fundamentally composed of a chain of blocks that store lists of verified transactions across a network. These transactions are validated and secure using cryptographic algorithms and consensus mechanisms. So go back here, you can see the blockchain is basically a chain of blocks, and you have a lot of blocks, like block 1, block 2, block 3. And on Ethereum right now, I think it's 25 million blocks already. And the block 2, the later blocks, the joint block is gonna coupling with the parent blocks, because the hash of the parent block is used to generate the hash of the later block. So to verify that two hash has the relationship together, you only need to use the parent hash, and to generate again the reverse hash, to generate again You only need to use like the parent hash and compare it with like the reverse hash of like current blocks to see like if they have like the relationship together, and in that way it's gonna like construct to like the whole linked list of blocks that heavily connected to each other. And some fundamental structure of the blockchain comprise of like the following key elements. So the block like contain like transaction data and a link to a reverse block, forming a sequential change. The transactions, which basically the activities on the chain, whatever you do on the chain is gonna like generate a new transactions, and all these transaction data is gonna be stored inside the block. The hash is the unique cryptographic signature for each block, like ensuring the data integrity and so linking all the blocks together. The node like are like computers in the network that participate in the network to maintain the copies of the blockchain, or I can say like to maintain the data, the public data of the whole blockchain, and participate in like validating the transactions. Validators are a special type of the node that responsible for verifying the transactions and adding the blocks to the chain. So if you want the chain to keep like producing new block, you have to have like the involvement of the validator in that role. Now we're talking a bit about the consensus mechanisms, and as we mentioned about like the node participate in the network, and the validator and the special type node like validator gonna like participate in verifying the transactions and adding the block to the network. We need like a kind of consensus mechanisms. We need a kind of mechanisms for like all the validator participate to the network to get to like the consensus. So now if like you have like 10 validators and you have like six good validator and 4 bad validator, how can like if like 4 bad validator trying to do malicious actions, the mechanisms need a way to slash them from the network and also punish them and encourage the good validator to keep doing well, keep doing good, to keep releasing blocks in the right way. In that way, we have the consensus mechanism that like have different rules to reward, to punish the network participant. The most common one is like the proof of work and the proof stack. So the proof of work is in the Bitcoin and also early Ethereum. Proof of work basically like all the miners, or like I can say like the node participate to the blockchain that using like proof of work mechanisms gonna become like a miner, and then it's gonna mine new blocks by like fighting the nonce, fighting the secret of the block. And in that way, when they find that out, they're gonna produce a new block and they're gonna be rewarded with the amount of block reward. For like the roof stack, all the stacker gonna participate to the network, and then but they have to stake have to stack the specific amount of the money. For example, like all the stacker in Ethereum have to stack like 32 Ethereums to be a part of the network. And all the stacker gonna participate to validate the network transactions, and whatever malicious actions are found by the network, it's gonna like slash the malicious actors from the network, and gonna like also punish them by taking the amount of punish amount from like the stack amount of the stacker. So here you can read like some descriptions. There are also like some more interesting consensus mechanisms from other blockchain, like root of history used by Solana, and also like nominated root stack, which is currently used by Polkadot. And aside from the consensus mechanisms, we also like have like different application area. We also have like different application area of the different blockchains, where we have like the public blockchain, which is basically the most well-known architecture of the today blockchain, like the Polkadot, Ethereum, Solana. And we also have the private blockchain, which is widely used by the enterprises to deliver solution, which is just specifically for the enterprise, but they still want to use the blockchain as a database. Consortium blockchain is kind of like a private blockchain, but like with different kind of like organizational level. And hybrid blockchains like partially public, partially private. Aside from that, we also have different layers of the blockchain architecture. So the Polkadot is categorized as a layer 0 infrastructure, where allow you to build like the layer 1 on top, layer 2 on top of it. On layer 1, we have like Ethereum, Solana, or Binance Smart Chain, where like these layer 1 are are kind of like widely well known. So the layer 2, on top of the layer 1, they don't have to maintain the active set validator, the active validator set. They can rely on the security of the layer 1 using like the layer 1 and the security hook. The attribute of the layer 2 is like it's quite fast, it's very scalable, and it can operate like 5 times, 10 times more than the transactions that the layer 1 that can process. I also want to mention a bit about the Web3 applications. So the architecture of the Web3 application, we have like the smart contract, incentive layer, distributed ledger technology, and network computing devices. And as we mentioned, like we have like the node that participate to the network and to validate the transaction on the network. And all those nodes are like kind of like the computers or the mobile phone participate to the network of the computing devices with the common knowledge of the network stakeholder. And the infrastructure is scaling on the global levels. Anyone can host a computing device to be a part of the network. And but like to ensure like all the data can like distributedly can distribute in the global scale, then like, we need a shared database across the whole network, like where like everyone like, can view where it's coming from. This is where like the blockchain involved, and all the application running on top tell what is want to get from the blockchain and what is want to change like the data of the blockchain. The incentive layer, I mentioned that in the consensus mechanisms that like is the incentive layer allow like to reward and also like to punish the actor who have malicious actions, or and also like reward the actor who doing well and producing new block for the network. And that's also like the end of like today's videos. In the next video we're gonna learn a bit about like blockchain programming.